Aloha. So in this problem, we're told that an athlete has a mass of 70.2 kilograms, and that when he or she's submerged in water, they have an apparent mass of 3.4 kilograms. Actually, the book says this is the actual weight and apparent weight, but kilograms, we're always talking about mass here. And this is basically like the actual mass on land. And this is submerged in water. So that's sort of like how you would feel later when in the swimming pool. So what's really going on here is that when you think about the forces, the apparent weight will be the actual weight minus the buoyant force. So that's why the apparent weight is a bit less than the actual weight. And the weight is the apparent mass times the acceleration due to gravity for the apparent weight, and the actual mass times the acceleration due to gravity for the actual weight. And the buoyant force we can express in terms of an equation from Archimedes' principle. So that's going to be the mass of the fluid displaced times the acceleration due to gravity. And we know this person is in water, so we know that this mass is really the density of the water times the volume of the person. So that's the mass of the fluid displaced times g. So you'll see that we can cancel out g, the acceleration due to gravity. And the first part of this problem, what we want to do is find the volume of the submerged athlete. So that really means we just need to find v from this equation here. So we can write this as v is 1 over the density of water, kind of adding this over to the other side and dividing by rho. And we have the mass minus the apparent mass, bringing this term onto this side. So the density of water is a known constant in a table earlier in the book. So that's 1,000 kilograms per meter cubed. And the mass here is given to us as well as the apparent mass. So you'll see that you'll get an answer in meters cubed, which is good. That's a unit of volume. You should get 6.68 times 10 to the minus 2 meters cubed. That answers part A when we're asked to find the volume of this person. Part B, we want to know the specific gravity of the person. And we're told that there's really like the actual volume is this volume that we just calculated minus what they call the residual volume, VR. And VR is 1.3 times 10 to the minus 3 meters cubed. So this is basically air in the lungs that we want to subtract out. So that's contributing to the buoyant force. And when we're looking for the person's actual volume, we're going to ignore that, the air there. And we want the specific gravity, which we'll label SG, and that's defined as the density of whatever object or material it is in question over a density of water. And we don't know the density of this person, but we are given their mass, and we have now a way to calculate their actual volume. And density is mass per unit volume, so I'll write that here. So that's this density of this person is the mass over the actual volume, still divided by the density of water here. So that's how we're calculating what we want to find, which is specific gravity. So we can just plug in all those numbers that were given. M is the 70.2 kilograms. we just calculated the volume. And we want to subtract off this residual volume, which we're told. So those are all meters cubed. Make sure you're using the right exponent when you plug this into the calculator. And then the density of water is 1,000 kilograms per meter cubed. So you'll see that the units of meters cubed will go away here in the denominator. And the units of kilograms also cancel out, which is good because the specific gravity is basically, it's a ratio of densities. It should be unitless. So if you plug all these numbers into a calculator, you get 1.072, so about 1.07, keeping it to 3 significant digits like we're given in the problem. And then in part C, we're just given a formula for the percent of body fat of this athlete. And I'm told that this percent is calculated using this formula in terms of the specific gravity. So all we have to do there is just plug in the specific gravity we just calculated. And it's good to approximate at the end, so you can add extra digits there, keep that number in your calculator when you calculate this. You should get about 12% as your final answer.